In the standard version of Starship, the biggest technical challenge lies in its heat shield tiles. But for the HLS version, the toughest part isn't about heat, it's the landing legs. Sure, SpaceX already has experience designing and landing rockets using legs. Just look at the Falcon 9. But the HLS is a whole different beast. It's 5 times heavier and far more complex, making a reliable landing system a whole new challenge. That raises a big question. If it's so hard, why not just get rid of the legs altogether? As Musk once said, the best part is no part. That's right. The HLS might actually be designed without landing legs. But how would it land on the moon? Let's find out in today's episode of Alpha Tech. Throughout history, every lunar lander from the Soviet Luna 9 in 1966 to NASA's Apollo lunar module, and even Blue Origin's Blue Moon Mk1 has relied on landing legs. Not a single lander has ever touched down on the moon without them. Their purpose is simple, but critical, to absorb the impact on touchdown and keep the vehicle stable on the moon's rough, uneven surface, blanketed with fine, powdery regolith that can easily give way. The same idea applies to SpaceX's Starship human landing system. According to the company's early design concepts, it should also have landing legs. But here's the strange part. To this day, SpaceX has never revealed any official design diagram or even a 3D concept of what those legs might look like. That's led many to wonder, is designing landing legs for the HLS really that difficult? Well, yes, it actually is. The main problem comes down to scale. Starship HLS is enormous, 9 meters wide, 52 meters tall, and weighing around 300 tons at landing. Now, imagine trying to safely set that down on the moon's surface, a world full of craters, rocks, and soft dust. If you use traditional legs, they'd have to be extremely long and strong, adding several tons of dry mass to the vehicle. They'd also need special systems to prevent one leg from sinking into a soft patch of regolith, which could instantly tip the whole lander over. Even SpaceX's experience with Falcon 9 doesn't help much here. Falcon 9 only uses 4 legs, lands on flat surfaces, and deals with Earth's gravity, plus it weighs just about 22 to 25 tons during landing. By comparison, the HLS under lunar gravity would weigh the equivalent of about 50 tons on Earth. But the landing site itself is far more dangerous, especially considering that HLS has a completely different design from traditional lunar landers. It's much taller, which means its center of gravity is also much higher, making it far more susceptible to tipping over if anything goes wrong during touchdown. So, why not skip the landing legs entirely and give Starship a completely different landing configuration? In fact, that was one of SpaceX's original ideas when submitting its HLS proposals to NASA. Back in April 2021, right after NASA awarded SpaceX the $2.89 billion option, a human landing system contract, the Starship team unveiled a bold concept, a legless lander. For the first time in over 60 years of lunar exploration, a crewed lander would touch down without a single landing leg. The idea came straight from Elon Musk's design philosophy. The best part is no part. Instead of adding 6 to 8 tons of folding legs, hinges, pistons load, sensors, cables, and pneumatic systems, SpaceX proposed using the entire base of the vehicle itself, as the landing surface, essentially turning the 9-meter-wide Starship into one gigantic landing leg. To make this possible, the lower rim of the ship would be reinforced with an 8mm thick titanium ring and a crushable skirt made of 3D printed aluminum lattice about 40 to 50 centimeters thick. This layer would deform in a controlled way, on impact absorbing up to 70% of the landing energy, similar to the honeycomb shock absorbers used on the Apollo lunar module, but fully integrated into the vehicle's structure. It's actually reminiscent of the early Starship prototypes like SN-10, which managed to land vertically without the kind of deployable legs used on Falcon 9. Here's how it works. In the final 10 seconds before touchdown, all 6 Raptor engines would throttle down to just about 5 to 8% of their full power. That's roughly 10 to 5 tons of thrust per engine, producing just enough force to let Starship kiss the surface at a speed of less than 1 meter per second. About 30 to 60 seconds earlier, a ring of hot gas thrusters mounted around the base would fire at a 45-degree angle, blowing away the loose lunar dust and compacting the ground beneath it into a firm surface about 20 to 30 centimeters thick, effectively creating a compacted landing pad. This layer could withstand pressures of roughly 25 kilopascals, about the same as the tire pressure of the Apollo lunar rover. SpaceX refers to this technique as plume surface interaction, or PSI. According to their CFD simulations, it could even level out slopes of up to 10 degrees, all without any mechanical landing gear or digging equipment. In terms of mass, the legless Option A design would have a dry mass of around 85 tons, saving 8 to 10 tons compared to a version with legs. That weight reduction could be used to carry an additional 7 tons of payload or extend crew operations by 3 to 4 extra days, thanks to the extra propellant capacity. All the complex hardware normally required for landing legs, 6 12-meter titanium struts, 24 hinges, 48 pneumatic pistons, 72 pressure sensors, and 18 electric actuators would be eliminated entirely. That means thousands of potential failure points are gone, and assembly time shortened by nearly 30%. Simpler, faster, and more efficient, that's exactly what SpaceX needs. But that's not the only way to land without landing legs. There's another even more radical approach, horizontal landing. And no, this isn't science fiction. It's a legitimate engineering proposal designed to eliminate 10 to 15 tons of heavy landing gear entirely. Here's how it would work. Starship HLS would still approach the lunar surface vertically, just like we've seen during test flights like Flight 11, and using its 3 Raptor vacuum engines, it would slow down from 1.6 kilometers per second to just 2 or 3 meters per second. When the ship reaches around 50 meters above the ground, the RCS system, a network of 48 small thrusters, would fire, gradually tipping the vehicle from a 90-degree vertical position to about 30 degrees over the course of 10 seconds. It's a maneuver somewhat similar to how the U.S. Air Force's X-37B glides onto a runway, except Starship would create its own runway. A composite landing pad about 50 centimeters thick would deploy from the belly of the ship, cushioning the touchdown and absorbing impact to under 3G. The advantages are obvious. Landing horizontally spreads the contact area to roughly 160 square meters, distributing the load to just 0.3 kilograms per square centimeter. Compare that to a legged configuration, where the pressure could reach 4 kilograms per square centimeter, enough to sink or tip the vehicle on the soft lunar dust. Think of it like walking on sand. The more surface area you spread your weight over, the less you sink. But if all your weight rests on just your 2 feet, you'll go straight down. And there's more. For astronauts, this design would be far more practical. They could exit the ship via a simple 3-meter folding ramp, instead of relying on a 30-meter elevator system like in the original concept. Most importantly, a horizontally landed Starship could serve as an instant lunar base. Its warm 100 cubic meter interior volume would provide immediate living space. The ship's surface could easily be covered with a layer of regolith, blocking up to 80% of cosmic radiation, and the side cargo doors would allow 2.5-ton rovers to roll directly out, no cranes needed. That idea sounds brilliant, doesn't it? But like everything else in engineering, it comes with trade-offs. First, the spacecraft itself. Starship's internal structure poses a challenge. Most of it was designed to handle vertical loads. Its tanks, cargo bays, and internal framework might not withstand a horizontal orientation without reinforcement. That could cause pressure imbalances inside the propellant tanks, leading to sloshing or even leaks. SpaceX would need some clever engineering to stabilize those systems in any orientation. Then there's the issue of returning to orbit. A vehicle lying on its side can't just take off. It has to stand upright again before launch. And lifting something that massive into position on the moon, that's an enormous challenge on its own. So realistically, the horizontal landing concept makes more sense for cargo variants of Starship, not the crewed version. For missions like Artemis 3, a vertical landing remains the most practical approach. However, the idea of a landing without landing legs has faced strong opposition, not just from engineers, but from NASA itself. In fact, during the Option A phase, both NASA and the Aerospace Safety Advisory Panel firmly rejected the concept in their Q4 2022 risk assessment report. They had good reasons for that. First, the lunar regolith isn't uniform. The surface layer can vary from 4 to 12 meters deep, with sharp buried rocks underneath. If one side of the vehicle sinks just 1 to 1.5 meters, the ship could tilt more than 25 degrees within 2 seconds, enough to topple over even with a weight of only about 50 tons under lunar gravity. Second, there's the plume ejecta problem. Even when throttled down, 6 Raptor engines still produce exhaust velocities exceeding 2,000 meters per second, easily capable of digging a 1 to 2 meter crater beneath the vehicle. That would destroy the compacted surface it just created, something already observed during NASA's L-Cross experiment back in 2009. Third, there's no redundancy. If even one of the 6 Raptors fails or its gimbal gets stuck, the vehicle would lose thrust balance and hit the ground at over 5 meters per second, far above the human rating certification limit, which requires at least 2 failure tolerances. And finally, without landing legs, the crew cabin sits close to the surface. Regolith dust kicked up during landing could cling to the underside of the ship and enter the cabin when the hatch opens, contaminating medical and air filtration systems. Because of all that, NASA issued a clear directive. A legged landing system with active terrain compensation is mandatory for crewed missions. SpaceX had no choice but to pivot to option B, starting in early 2023, redesigning Starship with 6 retractable landing legs made from 3D printed titanium lattice. Each leg is 12 to 15 meters long, weighs about 1.2 tons, and features adjustable pistons for around 15-degree on terrain, compensation, crushable honeycomb, dampers for backup, and real-time LiDAR sensors to adapt automatically to uneven terrain. So, what do you think? Which design makes more sense? A legless Starship HLS, or one with landing legs? Let me know your thoughts down below. Of course, before Starship can ever touch the lunar surface, there are still some massive hurdles to overcome. SpaceX first needs to perfect landing the vehicle back here on Earth, and more importantly, the orbital refueling system, a technology absolutely critical for any mission beyond Earth, still needs to be fully developed and tested. Without that capability, there's simply no path to the moon. Just a few days ago, SpaceX released a detailed update on the Starship human landing system, highlighting 49 development milestones that have been completed on time or even ahead of schedule. From that report, it's clear that the vehicle is now in the phase of manufacturing and integrated system testing built around the Block 3 Starship, which has been optimized specifically for the Artemis missions. Although not every detail was made public, the update gave us plenty of clues. The major components already developed include the crew cabin with avionics power systems, crew interfaces, and the environmental control and life support system. There's also the Orion docking adapter, and perhaps most importantly, the prototype landing legs, currently being tested on simulated lunar terrain. And of course, there's the Raptor engines, though. That part hardly needs any introduction, since SpaceX has already proven their capability many times before. The assembly of all these components into a fully integrated HLS Starship is expected to begin soon, which still keeps the program on track for Artemis 3 in 2027. However, based on the current pace, NASA might push the mission to 2028 or even 2029 to allow more preparation time. Because landing on the moon is anything but easy. It takes precision, patience, and a whole lot of testing. So, before Starship is ready to fly on an actual Artemis 3 mission, what does SpaceX still need to do? Well, first and foremost, SpaceX has to prove that its lunar lander can actually land on the moon. That's easier said than done, because the entire flight architecture is incredibly complex. It requires 4 different spacecraft working in sync: the HLS lander, a tanker, a propellant depot, and NASA's Orion capsule. However, according to NASA's official roadmap, SpaceX only needs to complete 1 uncrewed demonstration landing before Artemis 3 to earn human rating certification. And that's exactly the loophole SpaceX could use to speed things up in 2026. Under the HLS Option B contract, the company is allowed to perform a simplified demo mission using only the HLS lander and a single upgraded tanker without the depot or Orion. In that mission, Starship would launch atop Super Heavy from Boca Chica, perform 4 to 6 refueling operations in low Earth orbit over 1 to 2 weeks, then make the long journey to NRHO before descending to the lunar South Pole. It might sound simple, but it's not. SpaceX still has a long checklist to go through before that first lunar touchdown becomes reality. First, Starship V3 and Super Heavy Block 2 will need to fly as a full stack at least 3 to 5 times from Boca Chica, not just to achieve over 95% launch reliability, but also to prove that Mechazilla can perfectly catch both the booster and the upper stage. That's a make-or-break milestone for NASA's confidence in SpaceX's reusable system, since the Starship tanker is designed to fly again and again. This test campaign alone could take 3 to 4 months, putting the full tower catch demonstration around April 2026, just as Elon Musk himself hinted. Once that phase is complete, the second chapter begins orbital refueling. 2 starships, 1 tanker and 1 depot, will rendezvous in low Earth orbit, perform soft capture, then hard dock, and begin transferring hundreds of tons of cryogenic propellant in microgravity. Only after 3 flawless fuel transfers with no leaks, no freezing, and no system failures can SpaceX move on to the third chapter, proving that the propellant can hibernate in orbit for at least 30 days with boil-off below 0.1% per day, thanks to onboard cryocoolers. That phase will take time, too likely wrapping up by July or August 2026. Meanwhile, over at Starbase, the full Starship HLS system will be assembled and go through ground testings in parallel with the refueling trials, probably around March 2026. That timeline makes sense. Many of the components are already built, so assembly shouldn't take long. During this phase, the 6 Raptor vacuum engines could be test-fired down to just 20% throttle, pushing the limits of precision landing control. The environmental control and life support system will need to prove it can sustain a crew for at least 30 days straight. The pneumatic landing legs must handle lunar regolith without collapsing, while both the Dragon Eye and LiDAR navigation systems will be tested inside vacuum chambers and on simulated lunar surfaces. A prototype Starship might even attempt an analog landing here on Earth, touching down at less than half a meter per second, dust pluming along predicted trajectories, legs absorbing the impact perfectly. Only if those tests are flawless will NASA give the green light for the real HLS to launch into low Earth orbit, where the entire system will be checked out in space for the first time. If HLS ground testing wraps up around July, then August becomes the golden window. That's when Chapter 5 truly gets intense. SpaceX will attempt between 4 and 6 full-scale refueling flights, topping off the orbital depot with roughly 1,500 tons of propellant. By then, if Pad 1 at Starbase is operational, Starships could be launching from 3 pads simultaneously, 2 in Texas and 1 at LC-39A in Florida. That means the whole sequence could move quickly. Each tanker rendezvous and transfer takes only 2 to 3 hours, so in theory, the depot could be fully fueled in just 2 days if everything goes perfectly. But SpaceX always plans for contingencies. A 7-day buffer allows time to inspect the depot, verify stability, and ensure there are no leaks or thermal issues. Only then would HLS be cleared to launch rendezvous with the depot and load just enough propellant for TLI, LOI, and a soft lunar landing. Once refueling is complete, HLS will begin its 3 to 5 day journey to NRHO, testing optical navigation and DSN communications along the way. And if every system stays green, the final chapter begins an uncrewed landing on the rim of Shackleton Crater by late 2026, returning images, thermal data, and regolith samples. Proof that Starship can touch down on the moon, no Orion, no crew, marking a crucial step toward NASA's human-rated certification for Artemis 3. And that's the roadmap for SpaceX's first moon landing in 2026. Exciting, isn't it? If you can't wait to see that moment happen, drop a 1 in the comments below. Now, here's something even more interesting. While some NASA officials like former Administrator Jim Bridenstine and Sean Duffy have called the HLS architecture too complex, Elon Musk and the SpaceX team actually agree. That's why they've submitted a simplified lunar mission architecture to NASA for review, one that's not only easier to execute but also safer for astronauts. On their official site, SpaceX stated, "In response to the latest calls we've shared and are formally assessing a simplified mission architecture and concept of operations that we believe will result in a faster return to the moon while simultaneously improving crew safety. If approved, we'll finally get to see exactly how this new approach works and how it could reshape the future of lunar exploration. But actually, we don't need to wait to imagine what it might look like. According to experts, the Artemis 3 mission is currently complex in two major ways. First, it requires multiple refueling operations between Starship tankers and the Starship depot in low Earth orbit. Second, it involves repeated docking maneuvers between HLS and Orion in lunar orbit. So, if you had to simplify one of those two, which would you remove? Obviously, orbital refueling isn't optional. The Starship HLS needs around 1,200 to 1,500 tons of cryogenic propellant to make the full journey from low Earth orbit to NRHO land softly on the Moon, with a 100-ton payload and then lift off again. No spacecraft in history could carry that much fuel from Earth without sacrificing reusability or safety. That leaves the second one, the complex series of dockings between Orion and HLS. And based on recent analysis and reports from industry insiders, that's exactly what SpaceX's simplified architecture is expected to eliminate. The idea here is that instead of launching the crew aboard Orion, they could ride directly inside the HLS from the start. That would eliminate one of the most complicated steps of the mission, the multiple docking between Orion and the lunar lander, leaving only a single docking event when the HLS returns from the Moon. However, there's a serious challenge. The HLS currently has no launch escape system. For comparison, Crew Dragon is equipped with Super Draco thrusters that can push the capsule to safety in just half a second if Falcon 9 fails. Orion has its launch abort tower, which can pull the capsule away from SLS in case of an emergency. So if astronauts were to launch directly on HLS, the vehicle would need its own abort and crew safety system, one capable of separating the crew cabin in under a second if Super Heavy fails. The seats would need shock-absorbing structures, and there must be independent oxygen and life support supplies for emergency use. Adding all that would undoubtedly increase cost and engineering complexity. But if this approach truly makes the mission architecture simpler and safer, it might be a trade-off worth making. And perhaps it's no coincidence that, just as SpaceX moves closer to its first lunar landing, Elon Musk himself seems to be undergoing a major shift in focus. For years, he publicly dismissed the Moon as a distraction from his ultimate dream of reaching Mars. Back in January 2025, he even said, "We're going straight to Mars. The Moon is a distraction." But now that tone has changed completely. Musk is suddenly turning his full attention toward the Moon, treating it as a major milestone, a crucial stepping stone for humanity's future. In just a few short weeks between late October and early November 2025, Musk flooded X with posts about his plan to build Moonbase Alpha, the first permanent base on the lunar surface, claiming that Starship will be the vehicle to bring hundreds of people there. While his reasons remain unclear, two core objectives stand out. First, the Moon's extreme environment, glass-sharp regolith temperature swings of around 250 degrees, and 28-day light cycles makes it far harsher than Mars. If humans can survive, Musk argues that would be living proof we can thrive on Mars. Second, as Musk recently wrote, the importance of the Moon for scaling AI didn't occur to me until we did the scaling math on Earth to figure out what it would take to launch over 1 terawatt per year of orbital AI. Overall, this isn't just a tactical change, it's a transformation of vision. For Musk, the Moon is no longer a pit stop on the way to Mars. It's becoming the launch pad for Mars and for the future of artificial intelligence itself.